Okay, so let's get started. We're going to be taking a look at working with our mixture map feature found in our Link G5 and G4X programming. Our mixture map is going to act as an auto tune of sorts to allow us to dial in our main fuel table. Essentially what we have to do is drive and data log and capture a driving cycle, maybe 8-10 minutes or more, so that we can input it to the mixture map, and then it can figure out how far at various different cell points in our main fuel table. So let's jump over here from our basics page to our fuel. In our main table here, so whether we're in traditional mode or volumetric efficiency modeled mode, it'll figure out how far the particular cell point as we're operating in is off from our actual air fuel to our target. So it's going to be comparing a whole bunch of different variables. It's going to be taking a look at our lambda reading from our lambda sensor, taking a look at our target lambda coming from our target table, and then it can determine how far things are off and then allow an adjustment to that individual cell point. So this allows us to have more of a hands-off approach to calibrating our fuel table. We have to set things up correctly in order for the mixture map to work fairly well. We do also have to do some hand smoothing on our main fuel table oftentimes after we applied the changes from the mixture map. There's a lot of details to get this to work right, so I want to go through as much detail, setup, configuration here in this training module as possible so you have the best result with your mixture map function. Now, what we're going to do is move from our fuel page and jump over to our page here labeled mixture. This is the mixture map feature. On this page, you're going to find you have a blank area right here. This is going to be the mixture map, the overlay. We're going to learn how to actually work with this in a second. And then we have our main fuel table off to the right here. What we can find is that once the mixture map populates the data into the table, we can then transfer that to our main fuel table and access it right here rather than having to flip back into your fuel table window and make your changes in here and then flip back into the mixture map. So what we need to do is have a data log that we've captured already of a driving cycle for this mixture map to actually work and to do anything. So if I go and right click here, if we say update mixture map, nothing will happen because I don't have a data log open. So this needs to be using logged data, not live streaming data with your link. Now we've talked about how to data log, so whether it's going to be an onboard log or laptop style logging, laptop logging works perfectly fine for using the mixture map feature. We need to have that log file created and being able to open it up here in the software. So what I'm going to do right now is go to logging and go to open log file and open up a sample driving log file for you so we can take a look at this. So let's jump in here to our desktop and let's go into our G5 course packet, and then we'll go to our sample log file subfolder. In here, I have a log file labeled driving log sample mixture map. Let's go ahead and open this up. So we can see down here in our time plot window that this is going to be approximately 15 minutes long. This is a driving cycle in a Honda S2000 that was turbocharged. So it's just plotting all of the data and information from that logged, that laptop log in here into our time plot window. In fact, if we open up any single other tab or layout here, you'll find that same information found within the time plot windows. Now, we have to have a log file open to look at the mixture map feature. The next thing we need to realize with the mixture map, its intended purpose is to not have the closed loop correction turned on. Recall with our closed loop lambda correction, it's going to take a look at the target desired lambda at a given cell point, so a different RPM and load point. It's going to compare it to the actual, and then it's going to adjust things based on how far those two are off by. So the closed loop fuel correction is really ideal to get your engine up and running and to kind of sort out your fueling to your main fuel table. The problem is we technically can't have the closed loop correction on at the same time as trying to use the mixture map. So that can be problematic. So if you want to use the mixture map feature straight up and you don't want to have to do anything additional in the software, you need to make sure your closed loop fuel correction is turned off here. So we want to go up to the off option and turn that off. That'll allow you to log, drive, and then being able to use the mixture map as it's intended. I find that that's not very useful. I always like to run my closed loop lambda fuel correction whenever possible, as well as potentially my long-term fuel correction. We've talked about what the long-term represents here in our closed loop correction. We have our long-term tables that can populate and mature over several driving cycles. This improves our fueling to our engine, and then we can transfer what we find here in our long-term tables to our main fuel table to get an area of the table shaped up and get it dialed in, again, using our just driving cycles and getting things calibrated that way. With the mixture map, again, we have to be an open loop, so the closed loop technically would have to be off. That is going to be problematic in my opinion, and the best way around this is to use something called a math block feature. Let's go and create our math block right now, and then we're going to learn how we can integrate the math block into the mixture map setup so that it's going to be stripping away the closed loop short-term and long-term corrections, and then it allows it to function the way it's designed and way it's intended to be used in an open loop condition. So technically the way I'm going to be setting this up, keep closed loop on, we use a math block to mathematically take away the closed loop correction even though it's still being applied, and we can figure out our true lambda before the closed loop correction is applied, and that's what the mixture map will actually compare against and start to work from. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.